Hello, welcome to Online Chemistry. I'm Mr. Kruglinski, your science teacher. I am excited about learning online. I think there's a tremendous opportunity in it. For example, if I give a lecture and you don't understand some of it, you can just pause it, play it again, maybe look up a word that you didn't understand, really have some very deep understanding. So I love this idea of online learning. A lot of college courses are now offered online, so this is great practice for that. When you get a job, there's a lot of online activities. The boss wants a report online, wants you to keep track of something online. It's very, very common in the business world, so it's great to develop a literacy and a fluency with online technology. So we don't have much of a choice, but let's look at the positive ends of it. I think there's a lot of positives, so let's really try to make the best of it. I think it's going to be wonderful. Um, I'd like to still have an opening every day. I'd like to still have a 5-minute lesson. I'd like to still do a joke every Friday. So now that I've got my home set up to be a recording studio, we can start doing things like that. So I hope you're going to enjoy it. I'm so glad on Friday I did a survey. So a lot of you wrote about good things that are happening and some problems that you're having. When I get that information, it allows me to manage things better. I want to be the best teacher I can be. I want you to be the best student you can be. So please keep sending me email, keep sending me comments, and I'm going to be fixing things as I go along. I'm going to be try to improve things. The main idea is through this switch to online, you should not be deprived of any of your education. You should still learn all the chemistry standards. You should still have a full and rich understanding. You should still be prepared for college and careers. Wherever you want to go in life, you should have the education to get you there. So just because we're online doesn't mean your education should be less. I'm still going to be teaching all the standards. I'm still going to be rigorous, and it's still going to be a quality education. All right, you ready to do the opening? Let's take a look. Okay, here is the opening. I want you to write down the answer. If you don't know the answer, you can make a guess. But please pause the video at this time to write down your answer. Okay, are you back? Great, let's begin. Which measurement is more accurate? It looks like all the measurements are 10 grams. How can one be more accurate than the other? Well, stay tuned for the answer. Please remember that we have an extra credit assignment. Read The Mystery of the Periodic Table by Benjamin D. Weicker. It is due April 15th. I'm pushing up the date so you have time to get the book, read the book, and write an essay about the book. Remember that an essay is 5 paragraphs or more. You can't turn in 1 or 2 paragraphs and expect to get any extra credit. Either do the whole assignment or don't do it at all. You are not required to do it, but it is extra credit. All right, which measurement is more accurate? For me to reveal that to you, I will have to tell you a story. Yay, it's story time. All right, so once upon a time, you and I start a business, and it's a chemical business, and we're buying chemicals and redistributing them to different companies in the Atlanta area, and business is doing well. It's doing so well that we decide to hire 3 employees. And our first employee, we say, we want you to measure a certain amount of carbon-12. Tell us how many grams of carbon-12 we have in our inventory. And he does a very good job. He comes back and says you gave me 19.38 grams of carbon-12. Not just any old carbon, but of course a specific isotope of carbon-12, which weighs 12. So that was good. He measured it to a hundredth of a gram. Very nice. But our next employee was really impressive. She said, you know what? My dad works at Georgia Tech, and I can bring this sample of carbon-12 to him, and we can measure it on a really expensive, really accurate scale. I said, wow, that sounds really exciting. So I give her some carbon-12, not as much as my first employee, but she says it is 5.49167 grams of carbon-12. And I'm just floored at how accurate she was able to measure the carbon-12. Now, our third employee, I was a little bit worried about him. He was joking around a lot. at the job interview. I was afraid he wasn't going to be a serious worker. And here he is. He was a little bit silly at the workplace, and he didn't do a very good job. You know what he used to measure the carbon-12 we gave him? He used a triple beam balance from his high school. I was not impressed. Those things are not that accurate. I said with disappointment in my voice, okay, what was the measurement? He said, yeah, it was 8.9 grams of carbon-12. Okay, well, I know those triple beam balances aren't that accurate. I know that it might not be 8.9 grams. It might be a little bit more or a little bit less. So that's disappointing. Anyway, here's the three measurements from our three employees. And we need to take an inventory of how much carbon-12 we have in total. So we total it up, we add it up, and we get 33.77167 grams. And the question is, how meaningful is that number? And I'm afraid it's not meaningful at all. According to the rules of significant figures, we have to round. And we're going to round that to 33.8 grams. So what happened to the rest of the numbers? I mean, we had someone from Georgia Tech take a really accurate measurement. Yes, that's true, but when you add it to something that's not accurate, the whole total becomes inaccurate. So the least accurate number is 8.9 grams. It's only measured to 1/10 of a gram, and therefore our total can only be reported up to 1/10 of a gram and no more than that. So here's a rule in significant figures. The precision of your total is determined by the least accurate number that's being added or multiplied or divided or subtracted. So in this case, 8.9 grams was the least accurate. Therefore, our answer is going to also be not so accurate. To 1/10 of a gram and no more. Why is that? Well, let's say we remeasure all of these carbon-12 samples and we put those more accurate measures in red. So the person who said 19.38 grams, he was really close, but it was actually only 19.377 grams. And then the person who went to Georgia Tech, that was really impressive, but it turns out she actually had a little bit more than she thought. It's not 5.49167, it's 5.491672. And the person who used a triple beam balance, that wasn't very accurate because the real measure was 8.551 grams. And when we take these more accurate measures in red and we total them, we get a total of 33.469672. That is different than the total in black. Let's compare the two. Well, the 33 is accurate. We definitely have 33 grams of carbon-12. But when you're talking about 1/10 of a gram, we do not have an accurate measure in black, and that is important to recognize. Let's round them to 1/10 of a gram. The 33.77167 gram rounds to 33.8 grams, and then in red, 33.469672 grams rounds to 33.5 grams. So you see there's a difference between the two of 0.3 grams. Why is that important? Let's say we have a customer that says, I need carbon-12, I need it fast. Do you have 33.8 grams of carbon-12 in inventory? It turns out we don't. According to our math, we do, but in reality, and red is more realistic, turns out we don't. So what does it mean? It means that the 33 where it was accurate and the 0.8 or the 0.5 are inaccurate. They're estimates. And that's a rule with significant figures. You report your numbers very accurately, and the last number is allowed to be an estimate. And then once you have an estimate, you can't put on any more digits than that. So we added up all these values in black. We rounded to 33.8 grams. The 33 is accurate. The 0.8 is an estimate. As you know, that 0.8 actually is not a true number. It is a good estimate, though, and that's why we leave it. So we would say that this answer has three significant figures, the 3, and the 0.8. Two of those numbers are accurate, and one is an estimate. 33.8 grams. In measurement, in chemistry, the 33 is considered accurate. The 8 is considered an estimate. So when we round these two numbers, we see there's a difference between 0.3. That means the number that we got was accurate by 2 digits, and the last digit was a little bit inaccurate. It was an estimate. Let's look at another example. Here's 23.456 grams. When you're reading that with significant figures, you realize that 23.5 is considered accurate. This 6 is considered an estimate. Again, 123.4567 grams. The 123.456 is considered accurate. The last digit, the 7, is considered an estimate. It could be an 8. It could be a 5. We don't know. But it's probably someone around 7. It's probably not a 0 or a 1. It's probably a number around 7. It's an estimate. So it is significant. We would say that this number here has 7 significant figures, but 6 of them are accurate and 1 of them is an estimate. The estimate's still considered a significant figure. It's just less significant, and we don't put as much faith into it. So let's go back to the opening. Which measurement is more accurate? The answer is the last one. This is someone who measured to 100,000ths of a gram. And you're not supposed to put that many zeros unless you are really reporting honestly that you measured to that level of accuracy. The first one only has 1 significant figure. The 1 is significant and the 0 is not considered significant. But if it does come out to exactly 10 grams, then you're allowed to put a period, which indicates the 1 and the 0 are both significant. If you measure to a 1/10 of a gram, then you can say 10.0 grams. And if you measure to 100,000ths of a gram, then you can say 10.00000 grams. Let's put in red what those numbers really are. You can see that 10 grams was not very accurate. It was actually 11.63 grams. So the 1 was accurate, the 0 was an estimate. When you put a period after the 10, it means that I definitely know it's 10 grams, and the 10ths and the 100ths I'm not too sure about. If you put 10.0 grams, it means you actually measured to that level of accuracy. And if you have all those zeros, like the last number, it means you really measured to that level of accuracy. The only digit that's not allowed to be accurate is the very last 0. That's allowed to be an estimate, and you can see in red that it's not 10.0000000. It's actually 10.000002. The last 0 was an estimate. That is the lesson on significant figures, the end.